Alright, so in this video I'm going to talk a little bit about graphing. I'm going to show you how to graph data. This is information you should be familiar with from your math class. Now when I give you a data table, the independent variable is usually on the left side and the dependent is on the right. So this is basically on the x-axis and dependent is on the y-axis. So I'm going to put position in meters here. I'm going to put time in seconds here. Now how do I scale this? In order to scale this, I have, I think on the time axis it's pretty straightforward. It looks like I have, I think I have 35 boxes and I have a maximum of 5 seconds to put in there. So I want to figure out, well, how much is each one box worth in seconds? So it looks like it's 7 seconds. So now each box, I'm sorry, it's 5 over 35. So it's 1/7. So that's such an odd number. So this is 5/7. So I think I just to keep it simple, I think I'll just make this 1, 2, 3, 4, and 5. Now you want to use up most of the space you're given, but don't just try to stick yourself in here. In other words, don't make just this 1, 2, 3, 4, 5. It's too tiny. So you got to use up most of your space. On the other side, I have I have 35 tiny boxes, and I need to fit 50 meters in there. Okay. Now, which means each box is worth how much? That's what we're trying to do. Okay. So each box is going to be worth 50 divided by 35, which is 10 over 7. Now that's a very odd number. So 10 over 7 is what 1 point, was it 30.4 something, right? So I think I'm just going to make each one of these boxes. I'm going to round up higher, because if I go down, I'm gonna run out of space. I'm gonna make every tiny box a 2 from here. So I think, which means this is a 10, 20, 30, 40, and 50, right? So now, and sometimes you don't even have to do these proportions. You can pretty much just see. Now we have to give a title to this graph. So this is always the dependent, which is position, versus the independent, which is time. That's the title of our graph. You have to put a title. Now, if you look at this data, you probably should notice that it's a linear fit. It wants to be a line. But let's see if we can confirm that. So now I'm going to start graphing my data. 0, 0, 1, 11. So here is 1. Now, 11 is not one box after the 10, because each tiny box is a 2. So it's going to be like halfway in between. 2, 20. That's an easy one. 3, 29, 3. Now 29 is not one below 30, but it's half below 30. 4, 40 and a half. Now 4, 40. 41 is halfway, so 40 and a half is a quarter of the way, which is hard to do. 5 is 50. 5 puts us here. Now you can see that this data wants to be a line. Now how do you draw your graph? Well, you draw the line of best fit. Now, you have to leave, it has to pass by the majority of the points, okay? And it doesn't necessarily pass through the first one and the last one. That's a misconception. And you have to leave an equal number of points below the line as above the line. So I'm going to try my best here to do that. So I'm going to go this line here. Okay. So I'm leaving one here, and a tiny bit up there, which is okay. So if you have an odd number of points, you can leave 2 on one side and 1 on the other. Now the other thing is We labeled it. I want to write an equation. Now, this is just the equation of a line. So instead of writing y, I'm going to write p for position, because that represents the y-axis, equals the slope, which I think I can figure out. Now, if I want to figure out the slope, I always pick points that are further apart. So this way, if I make an error, it's not severe. So I'm going to pick these 2 points here. So it's a rise of 50. Don't just count the boxes. You have to count the boxes, and you have to count the face value of the boxes. So this is a 50, a rise over run. So it's 50 over 5, that's a 10. So mx, x is t, plus b, which is the y-intercept, that's 0. So basically this equation is about p equals 10t. Some of you might find 9.5, 10.5, but it should be around 10. Okay? And it all depends on how you draw your line of best fit. Okay? All right, I'm going to look at some other data that I want to graph, but this time it's not linear. And just by looking at it, you can tell that it's not linear. So again, I'm going to put my time here in seconds. I'm going to do the same as before. 1, 2, 3, 4, 5, 6. It's going to be position versus time. And then I'm going to put my position in meters here. Now I have to get up to 76. All right, so let's see what we can do with that. All right, so I have 35 boxes, and I need to fit 76 meters. Equals each box is going to be worth how much? So it's going to be 76 over 35, which is what, 2 point something. Calculator. So we can try to do this. So 60, so it's 2 points, almost 2.2-ish. That's an odd number. So I'm going to go for 2.5 each box. So this is 2.5. Okay, so 10 of them will put me at 25. So I'm going to put 25 here. I'm going to put 50 here. And I'm going to put 75 here. Okay? Now, keep in mind, each tiny box is 2.5. One box is 2.5 meters equivalent. Okay? Okay. Now, I'm going to start 0. Okay? 1, not 0, 0. So this is 2.5. 1 is kind of like there. Okay? Just a little bit less than half the way. 1, 4. 1. So now this is 2.5. That's a 5. 4 will be somewhere in there. Okay? And you can figure out how much 4 is. So because one box is 2.5 meters. Well, I can do it the other way. One box is 2.5 meters. How many boxes do I need for 4 meters? So you just do 4 divided by 2.5, and that should give you how many tiny boxes you're gonna need. So that's gonna be about, so it's 40 over 25. So if I reduce it, it's gonna be 8 over 5, right? Yeah. So it's gonna be 1.6-ish. Okay, each box. 4 meters is 1.6. So it's 1 and about 2/3. Okay, it's hard to do some of them. 213. So now this is 2.5, 5, 7.5, 10, 12.5. 13 is right there. And you can do this proportion to figure it out. 449. Nope, and it's 328. 3, that's 25. It's 27.5, so just a little bit above. In other words, a fifth of the way. Okay. 449. 4, that's 47.5, 49, so I'm going to be like 2/5 of the way shy of the 50. And then 576. 5, that's 75, that's 77.5. 76 is a little less than halfway. Now, this one does not look linear, so you have to take one of those flexible rulers, and you're going to graph it. Okay, so you follow it, you follow the curve. Now, writing the equation of this is not easy, but I know that it's a quadratic fit. Let me make sure that it's still recording. Yeah. I know it's a quadratic because it looks like some sort of a parabola here, right? So now how do I write the equation? I know it's going to be P, which is y equals, it's going to be y equals mx squared or ax squared, because there's no slope here, plus b. And the b is just 1 basically, that's the y-intercept here. Now, you have to kind of like just see the pattern. Okay, so it looks like it's going to be 3t squared plus 1. So let's see if that works. So 3 times 1 squared, that's 3 plus 1 is 4. 3 times 2 squared, that's 12 plus 1 is 13. 3 times 3 squared is 27. So it's 27 plus 1 is 28. So that works. Okay, and that's pretty much how you graph. Okay. Now when you do it in LoggerPro will actually tell you the equation of the line. All right. Thank you.